Hey, so this is going to be our lesson for 4.3, writing linear equations from context. So, word problems. Let's highlight the learning target. I can apply intercepts and slopes to real-world examples to form linear equations. So, we can figure out we're going to learn what intercepts and slopes represent in real-world problems, and we're also going to be able to solve them. Okay, so first we need to think, what are these problems going to look like? So we have slope-intercept form. That's the one we know and love. Y equals mx plus b. And we also have standard form, which we have seen before, but it's a little bit newer. It is ax plus by equals c, where a, b, and c are just random numbers, and x and y are variables. Okay. And then this question is asking us about the rate. What is another word for rate? Slope. So take a look in here. What is the slope of this equation? It's always going to be the number attached to the x. And whatever sign goes with that number stays. So -6 is going to be my rate. Let's talk about words in our homework that we'll see today that represent different parts of our equation. Words that you're going to see that represent slope. There's not a lot of them, which is nice, but they're there. We've already seen one. That one word was rate. So you might see the word rate on your homework, like it'll say a rate of miles per hour or something like that. Okay. Another one that you might see is each. So like for each apple, like how much is it? A very common one is per. So let's take that one and then highlight it because you will see that a lot. And then you might also see the word change. So those are words that represent slope. Words that represent the y-intercept. Remember, that is our b in y equals mx plus b. Slope is the m. In b, you might see the word fixed, meaning a fixed price, a price that will not change. You might see the words initial value, or we're going to think initial value because it's going to be like our start. So there's another word, our start. One of the words I see that's specifically on your homework is the word guaranteed. Hopefully I spelled that kind of right, but you're going to see those words quite a bit, and those represent the y-intercept. Words that represent our math operations. So plus sign, obviously maybe the word plus, or add. You might see the word and. So if I say this and that, we would put them together, which is adding. Or you might see the word give. For subtracting, think take away, the word subtract, and minus. For multiplication, you might see this, it'll feel a little weird, but you might see double or triple or something like that. And for dividing, you might see like cut in half or a third. So if we see fractions, that's dividing. If we see double, triple, That's times 2 times 3. Okay. Let's flip the page and put it into practice. So there's one of our word problems. Like I said, you can get different looking problems. So they can either be in y equals mx plus b, or they can be in standard form. And it depends on what it's asking. So, or what information they've given us. Let's put it that way. First of all, in y equals mx plus b, there's only one rate. So that means there's only one per thing. There's only one thing that's changing. So, reading through this example problem, at the end of the snowstorm, Jeremiah had 17 inches of snow on his lawn. The temperature then increased and the snow began to melt at a rate of 0.5 inches per hour. So between those two words, I'm thinking that is my M. That's going to be my slope. Okay. Assuming no more snow is falling, how much snow would Jeremiah have on his lawn 3 hours after the snow began to melt? How much snow would he have on his lawn after T hours? So that was taken directly off of Delta Math. You'll notice the 17 that we had up there, that's what I was starting at, right? Before the snow started to melt, I had 17 inches of snow on my lawn. So that's going to be my B. And if I'm melting, we got to think about this for a second. If I'm melting, is that taking stuff away, or is that adding more snow? Like, am I taking away snow or am I adding more snow? So if it's taking away, then I'm going to subtract from my initial. I'm going to subtract my rate. And we wanted to know after 3 hours. So this was inches per hour. I want to know after 3 hours. So per means this is my slope. The 3 is my x. And the 17 was my b. And when I plug that into my calculator, I get 15.5. Okay. Then the next part of the question, this is from Delta Math as well. It's going to ask you for 3 hours, and then it's going to ask you for T hours. And when they ask for T hours, they want the expression that you used. So we used 17 minus 0.5 times my rate, or times my x value, or my input, the 3. Instead of the 3, I'm going to put a T. And these are the two answers I would put into Delta Math. Okay. Standard form. So this is, let's take our highlighter. If we're measuring 2 different things. So you'll notice I have 2 things that I'm thinking of now. Whereas before, I just had the one. I had 3 hours in the last example. Now I have 4 bottles of soda and 7 bottles of juice. So 2 different things. And we're going to multiply each of the variables by their per value. And that's going to be our AX and our BY. So with our highlighter, at a local mini mart, a bottle of soda is 85 cents. And a bottle of juice is 95 cents. What would it cost to get 4 bottles and 7 bottles? So 4 bottles of soda and 7 bottles of juice. My rule for myself when I'm doing these is we want to keep like things together. Okay, so I'm not going to put the rate for soda with the number of juice. I'm going to put soda with soda and juice with juice. So 4 bottles of soda times the value of the soda, which was 0.85. And then I'm going to put 7 bottles of juice with the rate for juice, which was 95 cents. And if I'm at the grocery store and I'm racking up my bill, what they're doing is they're adding all those values together. So we're going to add them together too. And you'll notice this creates my AX plus BY that we saw right here with a plus sign in the middle. Okay, when I plug this into my calculator, I get $10.05. Okay, now if I am going to write the expression like I did before, I'm talking about X bottles of soda and Y bottles of juice. Well, the 4 is replacing the X, or the 4 is being replaced by the X and the 7 is being replaced by the Y. So I'm going to do that in my expression. I'm going to say X 0.85 plus Y 0.95. When there's nothing in the middle, there's a times. Oh, no equal sign. So this is what I would put in a Delta Math. These two answers. Okay, so like I said, the rule is keep the like things together. If I had to pick a rule for the top one, I would say you need to find the slope and you need to find the start. Okay. Lastly, this one's kind of fun, but it ends up being a little tricky for us because it's written the exact same way as this one right here. They're both going to be in standard form, except we don't multiply at all because we're not being asked about the value of the thing. So we're not going to be inputting the actual, what am I trying to say? We're not putting in the actual cost like we were before. This $10.05 was that. It was money. Now it is asking me for the total coins. So if I have 12 nickels and 4 quarters, how many coins is that? Not how much is that worth. So what I'm going to do is I'm going to say 12 plus 4. Because that's how many coins I have. I have 12 nickels, 4 quarters. 12 coins and 4 coins. That's going to equal 16. And so instead of having to do a bunch of stuff, I can then replace 12 with X and 4 with Y. And that is what I put into Delta Math, is 16 and X plus Y. So it can be a little tricky because you really need to read what it's asking for. Okay, in my question, it's asking for the amount of coins. Whereas in the last one, it was asking for the cost or the value of the soda and the juice. Okay. Feel free to try out the bonus for a little bit of extra credit. But that is 4.3. Thank you.